Okay, starting with what we need to know. This video is going to be a relatively short video because all I need to do is to teach you how to recreate a table for special angles. Whenever you hear me refer to the idea of special angles, we're talking about these angles of 30 degrees, 45 degrees, and 60 degrees. And you can create 45-degree angles inside of an isosceles right triangle. There's your 90, so that leaves, if these two sides are congruent, that leaves 45 degrees for each angle. And you can create 30 and 60-degree angles by taking that equilateral triangle with all three sides congruent, and when you drop that perpendicular down the middle, you end up with 30-degree angles at the top of each triangle and 60-degree angles at the base of each triangle. And we actually saw that on an earlier assignment sheet. So we're going to learn how to memorize exact values for 30 degrees, 45 degrees, and 60-degree trig functions. Anytime the instructions ask you for an exact value, you're going to be needing these numbers, and that's why we want to memorize them. We could recreate them every time, but that's not going to be a very efficient way to do it. So let's start with the fact that all 9 of these blocks will be fractions. Let me just draw, but we're going to end up doing the first 2 rows. So I'm going to make fractions in the first 6 boxes. We'll worry about the tangent a little bit later. That's kind of easier to calculate than it is to memorize. So starting with up top where we have the sign of 30 degrees, that's a fraction. Its denominator is a 2. As a matter of fact, all the denominators here are going to be a 2. So let's go ahead and let's put 2's in all of our denominators. And then it's going to be a very easy pattern on the top. The pattern is 1, 2, 3, and 3, 2, 1. We're almost there. The last thing we want to do is you want to take the square root of every numerator. Well, you don't really need to put a square root over 1. The square root of 1 is just 1. We'll put a square root over this 2, we'll put a square root over this 3, a square root over this 3, and a square root over this 2. And now you have your sines and your cosines for all 3 of those angles memorized, quote unquote, because you don't have to memorize them if you can just recreate the table. Let's move down to the tangent. We already saw that tangent is the same as, if you have a tangent of an angle, it's the same as taking the sine of that angle divided by the cosine of that angle. So what we'll do is we'll just put the top box over the box underneath it and do a division problem here. When you turn this into a division and your denominators are the same, anytime you're dividing 2 fractions, the denominators are the same, those blue 2's will cancel out. So this really starts out as 1 over square root of 3. We're going to return to that one in a second, and you might know at this point why. Let's take a look at what's going on here. Well, you've got sine and cosine the exact same number. When you divide 2 of the exact same number by each other, you end up with a 1. And then over on this side, well, again, those denominators of 2 are going to cancel out. Square root of 3 over 1 is just the plain old square root of 3. We're almost done. The only problem here is that we have a square root in the bottom of the fraction. We have to rationalize it. We'll move the square root of 3 to the top of the fraction, put a plain old 3 on the bottom, and so there we've recreated our table of special angles, and that's what we want to use every time we're asked for an exact value. Okay, we'll do that one more time just for practice. This time I'll go a little bit faster. We're going to begin by making all 3 fraction lines on top, all 3 fraction lines on row 2. We'll put denominators of 2 under all the fractions. Pattern for the top is a 1, 2, 3 and a 3, 2, 1. Lastly, we'll go put square roots over anything that's not a 1. And again, that's in the numerator. Got the sines and the cosines all done. We'll move down to tangent. This is 1 over square root of 3, but remember we rationalize that. Dividing the same number here by itself, we end up with a 1, and this is square root of 3 over 1, or just plain old square root of 3. Moving on to what we need to understand about that, whenever you are asked for the exact value of a function, you can go to that special angle table. Well, There are three angles in the special angle table. There's a 30, there's a 45, and there's a 60. So we can answer this last question. The exact value of cosine of 45, all we have to do is look at what we wrote down in the previous table, find that entry in the table. And when you look at that table, you see that entry for cosine of 45 degrees is right here. It's square root of 2 over 2. So there's not a lot of guesswork. It's just a table lookup. There's really no calculations to do just to come up with that simple answer. We find the exact value of sine of 180. Well, that is a special angle, but it did not appear in the table. The reason it didn't appear in the table is because it's a quadrantal angle. So for the exact value of 180 degrees, you can just go straight to that point minus 1 comma 0. Sine of 180 is equal to 0. That's going to be our answer. But when you have those quadrantal angles, your calculator will also provide you with the answers. So you can choose to use your calculator. Just remember, if you're using your calculator, you have to be in degree mode. So I'm going to show you that one more time. If you go to Home and you go to Settings, choose Document Settings. Float should be your first choice for display digits, and your angle must be in degree. And if you're going to change that to degree, then be sure you tab all the way down and say Make Default. When you say Make Default, that means it's going to stay in degree mode for you for the rest of your test or the rest of your homework or whatever. Okay, so the kinds of problems we'll be asked to do. Find exact function values. Tangent of 30 degrees. Look it up in your table. That's just square root of 3 over 3. You'd be done. Sine of 60 degrees. Look it up in your table. Sine of 60 is this cell right here, so it's a square root of 3 over 2, and that's all that requires. Cotangent of 45. Well, remember that the cotangent is the reciprocal of the tangent. So if we can find tangent of 45 in our table, the tangent of 45 degrees is equal to 1. If you take the reciprocal of 1, that's still 1, so that would be your answer. And then the cosecant, remember for the magic hexagon, cosecant is the reciprocal of the sine function, so we'll take a look at the sine of 60 and we'll flip that fraction over. The sine of 60 degrees is square root of 3 over 2. So if I had the sine of 60 at the square root of 3 over 2, and I take the reciprocal of that, I end up with 2 over square root of 3, but you wouldn't leave it like that. You'd bring that square root of 3 up top, put a plain old 3 down the bottom, your answer would be 2 square root of 3 over 3. And at this stage of the game, there's really only one other thing we might do with these angle lookups here, the special angle lookups. Tangent of 30 degrees is square root of 3 over 3. The cotangent of 45 degrees, I think we did that one up here. And we know that's equal to 1, so I might be asking you to perhaps add those two values together and give me an exact answer. And in this case, since that's an irrational number, you're not going to be able to do anything better. You could change the form of this. You could change this to a 3 over 3, and you could write 3 plus square root of 3 over 3 and circle that, but that's the same thing as that. This is actually a more simplified version up here. Cotangent of 45, we know that's a 1. Cosecant of 60 degrees, we found that up top to be a 2 square root of 3 over 3. This means multiply. So we're going to take 1, multiply by 2 square root of 3 over 3, and our answer will be just 2 square root of 3 over 3. This part where you start doing adding and multiplying, that may require you to come up with common denominators and to come up with then to multiply fractions. And be sure you're providing simplified fractions, no radicals in the denominator, and everything is reduced.